Hi, it's good to meet you all. My name is Pranshu. I am the head of product at Materialize, and I'm joined here by one of my colleagues, Sid, who is field engineer at Materialize. Uh, we're here, of course, mostly to talk about Materialize, not the two of us. So what I would love to do is we're going to share a lot about what we've been building recently. So we're going to give you all some feature updates and a short demo at the end as well. So why don't we jump into it? We're specifically focusing on the V26 release. So if you follow our release notes or our blog closely, you'll know it's been out a couple of weeks ago. So we'll show you a little bit about what's new. Sid is going to lead a demo for us of one of our key new pieces of functionality. And then finally, we'll have some time at the end for Q&A. Okay, so if you're new to Materialize and if you've not used our product before, you're not familiar with us, we are, in short, the live data layer for apps and agents. So engineering teams use Materialize to transform siloed operational data into a live digital twin of their business. And what's cool is that you can do this entirely using just SQL. That's key, right? Using SQL is a big part of the value here because it means that Materialize is really easy to use. You don't need to hire specialized talent. You don't need to hire specialized teams. Existing teams can operate and run Materialize at a fraction of the cost and time of other comparable approaches. And so we're seeing a lot of traction. Large enterprises amongst the Fortune 500, including companies like General Mills and Build, are using us today for context engineering for their AI apps, event-driven workflows, and then building data-intensive UIs as well. So that's a bit about Materialize in general. Let's jump into the V26 release. I'd love to walk you through some of the new functionality that's here, why we built it, and then, like I mentioned at the end, we'll have a little demo. So there are three key themes shaping the V26 release. The first is that we want to make it easier to operate Materialize in production. And that means making seamless changes without downtime, especially when it comes to incorporating schema changes from your sources. The second thing is enterprise security and improved access controls. We'll have a couple things to share here in a second, but we want to make sure that connecting to Materialize within air-gapped enterprise environments is secure and meets all the compliance standards that you need. And lastly, efficiency and performance. This is always a focus for us. We're always trying to push the needle on improving performance for Materialize. So we've got some improvements here that make Materialize substantially cheaper to operate without having to increase, without any sacrifices in performance. So let's dive into the details here. Let's start right up the top. The first major update in the V26 release is that you can handle upstream schema changes from Postgres sources connected to Materialize. So again, if you're new to Materialize, I think the best way to think about it is that one of the things that Materialize is able to do is seamlessly ingest data from your OLTP databases like Postgres. And what Materialize is going to do is it's really going to ingest live data and the associated schemas constantly. And in this way, Materialize is able to stay up to date with any changes in your source database. But because we are constantly ingesting live data and the associated schemas, you could understand that when that schema in your upstream database changes, it has the potential to break the flow of data entering Materialize. So historically, Materialize has prohibited upstream schema changes. If you change the upstream schema in your Postgres source database that's connected to Materialize, ingestion in Materialize would just stop. So as of V26, that is no longer the case. So what we've introduced with V26 is the ability to handle upstream schema changes, such as adding a column or dropping a column from your source Postgres database without any downtime in Materialize. So the eagle-eyed amongst you, the ones who've used Materialize before, you might notice the syntax for doing this is now very slightly different than what you were accustomed to. Don't worry, the old source syntax works just the same. We'll give you a good demo of how this works in detail in just a bit. But this allows you to basically create multiple versions of your sources, allow them to hydrate in the background, and when they're ready, swap over to the new version that incorporates the schema changes and drop the old one. So I mentioned dropping columns. That ties into the next release and the next feature update here. And that's something called exclude columns. And again, this ties into Postgres sources. So exclude columns is useful for two things. And the first is, in conjunction with the feature I just mentioned previously, if you want to drop a column from your upstream source Postgres database, you can use exclude columns to make sure that that happens without any downtime in Materialize. And the second thing that's also useful for is if you're trying to ingest data from a very large Postgres table, but you don't need some of the columns that exist in your source database. Using exclude columns can help you avoid ingesting a few of the unnecessary columns and thus speed up the initial hydration times and the initial snapshot times. In short, it makes it faster for you to get data into Materialize. Okay, both of those features are available now across our cloud product as well as our self-managed product. We're going to come to a couple of things that are currently just for the self-managed product. The first one of those is improved security with SASL Scram. So one of the important things for us, of course, is that with our self-managed product in mind, like the typical user profile and the typical kind of company that's using it is large enterprises with air-gapped security needs. So we now support SASL Scram authentication to help those kinds of customers. If you use SASL Scram, what this means is that when connecting to Materialize, the client and the server are going to use cryptographic proofs to validate identity. What that means in practice is that passwords are never exposed over the wire, and it makes the connection a lot more secure. There's a lot of practical utility to this other than the simple act of validating identity. One of the cool things that this unlocks is the ability to use connection poolers like PG Bouncer without having to store plain text credentials. I introduced a bunch of jargon here. PG Bouncer is a connection pooler, and what that does is that it maintains a fresh pool of connections to the database and thus giving you improved performance. So if you have high QPS requirements on Materialize, you can use a connection pooler like PG Bouncer to manage connections to Materialize. But PG Bouncer and similar connection poolers obviously require credentials to access Materialize. Typically, you store those in a configuration file. If you use SASL Scram, to come back to what we just released, instead of storing plain text credentials in a file, now you can use hashed credentials. And that means that it's a lot more secure for you to have connection poolers like PG Bouncer connected up to Materialize. Okay, we're going to get to one last thing. This was actually released on cloud before we released it on our self-managed product, but that's Swap. And what Swap really lets you do is get more performance out of smaller amounts of memory. Swap allows us to spill data to disk and allows us to do this intelligently in a way that does not affect performance. Previously in Materialize, if you've used Materialize for a long time, you know that we require quite a lot of memory and require holding quite a lot of memory to operate effectively. This is expensive because memory is expensive, of course. But with Swap, what that means is that in practice, you can use less memory and more disk to run the same workloads. We shared some stats on the right-hand side over here for some of the metrics that we have seen with our customers, whether they've maintained the same workload size or reduced cluster sizes and achieved similar levels of performance. But what Swap is really about is cost efficiency. You get a lot more value out of Materialize using Swap because it allows us to spill data to disk as opposed to holding everything in memory. This was enabled in our cloud product. If you attended our previous webinar hosted by Alex, you might know that we now have new clusters in our cloud product that incorporate Swap by default. We've now made this the default for our self-managed product as well. So if you start a new self-managed installation and you start v26.0 or v26.1 from scratch, you get Swap right out of the box. And that's cool because that means you have a much better unit economics for using Materialize today. Okay, so if you want all of the details, feel free to check out our launch blog that's over here. I will say that we released v26 a few weeks ago, and we are already on v26.1. In fact, v26.2, if I'm not mistaken, v26.3 is going out tomorrow. We've done weekly releases for our cloud product for quite some time, but we've now got our self-managed product on the same cadence. So if you're a Materialize cloud user or a Materialize self-managed user, you're getting the identical version of the product at all times. If you're a self-managed user, don't worry. You don't have to upgrade every week. Of course, you can upgrade at the cadence that makes the most sense for you. You can safely skip minor upgrades. So if you want to go from v26.1 to the future v26.12, that'll be totally fine. And you don't have to go sequentially through all of it. But definitely do check out the blog post if you would like all of the details for some of what I've just mentioned. We're going to do something more fun, though, which is that we are going to go into a live demo showing us how you can handle upstream schema changes from your Postgres sources. So I will pass it over to Sid to lead us for this.
Thanks, Pranshu, for sharing all the exciting information about v26. I'm going to show a demo of source versioning. This is the first 2 slides that Pranshu had covered during the updates. This is going to include like the new syntax and also exclude column, which are really exciting. And it's cool to demo this because this is one of our most frequently asked for features. And this capability will allow our users to use Materialize a lot more easily and also develop a lot quicker on Materialize. And let me share my screen. All right. So the setup I have going here is I have a production Materialize instance, and I have got one on my left. I have my Materialize instance that my developers use to make changes to Materialize. On the top right, I have my source Postgres database that Materialize is reading from. And on the bottom right, I have my Materialize consumer that's reading from the sales table that you see here. And we have values of 42 and 43, so the sales are going great. And covering what Pranshu said earlier, with our new source versioning, we've slightly modified the syntax in order to enable this feature. Before, you would use the subsources or create source for subsource, all subsources, or add subsource. We've replaced that syntax with simply tables. And the old syntax is still supported, but in order to use the new source versioning feature, you're going to have to rewrite your sources or blue-green your sources into this for all tables format. So I've gone ahead already to create my source from this Postgres database, but I thought it was great to call out what that's going to look like. Now, let's say that in my upstream database, I want to add in a new table. So what I'm going to do is I'm going to add in a new column, Boolean or important, into my database. And then I'm going to add in a new value into here. 43, true. If I go back to my consumer, it doesn't pick up those changes, but we do see that new row came in. So how am I going to include my new column in my source or in my Materialize source and seamlessly add this for my downstream consumers? So I've altered my upstream Postgres database. What I'm going to do now is I'm going to create a new version of the table that called sales v2 that's going to reference that same upstream sales. So I've created that table, and now I'm going to replicate my downstream Materialize views, indexes, whatever it may be, to use this new column that I've created. So I'm going to go ahead and create a new Materialized view, sales mv2 as select star from sales v2. All right. Now I've created my new Materialized view, and this sits alongside the current existing one that we see here that our Materialized consumer is using. I'll go through all my developments and my testing to see how it is. And whenever I'm ready, all I'm going to do is simply do a alter schema swap or a rename in order to get my sales view, in order to get my sales v2 to be my sales view. So for the simplicity of the setup, I'm going to drop the table first, but you can do a blue-green deploy to do it. Sales, I believe it's sales MV. And then now I'm going to rename my alter materialized view sales MV2 rename to sales MV. And now here, if I selected from sales MV, I'm going to get that new column. And excuse, this was meant to go from sales MV to begin with, but basically you have a seamless approach for your downstream consumers to see this new column without experiencing any changes or recreating your sources. Now let's go into the next scenario, which is you want to remove a table, or sorry, you want to remove a column from the database. This is where we're going. So let's first, for this one, we're going to use our exclude column feature. What we're going to do is we're going to create a new version of our source, sales v3, that excludes this new important column that we added. And just for reference, if I show you what's in the sales table, select star from sales, I have this important column. So we've added it in, we don't really like it anymore, so we're going to remove it. What we're going to do is create a new version without it. And so now we have our new version. We're going to once again create our materialized views, downstream objects that read from this table in the source. So I'm going to once again create materialized view, sales MV3 from, or as select star from sales V3. Go ahead and went ahead and created it. Now, let's say I want to read from it from here to see what's going on. It's going to be MV3. I only have my existing values, not my important values. And while this is all going on, my downstream consumer is not going to see any changes. So if I once again read from the existing view, they're still seeing that important value, but I've created a version that doesn't exist with it. Whenever you're ready now, you can simply swap as you did before. So I don't have separate schemas set up, so I'm going to actually drop and rename, but you can do the alter schema swap as you do with blue-green deploys for 0 downtime. So I'm going to drop materialized view, sales, MV, and then I'm going to alter materialized view. This is sales MV3, rename to sales MV. And now our downstream consumer is going to see that that table once again without the important column added to it. And what this really unlocks is that before, when you were removing a column, let's say, or making a change to your upstream database, we would have had to go through the process in our Materialize, like internally in our Materialize operations, to actually recreate that source from scratch, which was that command that I showed up here. Let me add that. I would have had to recreate my source and recreate my objects. But with source versioning, we can reuse that source and connection object in order to just create versions that we can just alter and swap without breaking or like having a seamless transition from one version of the source to the next source version. And this is really great for your production use cases that maybe you're adding new data to or making changes to, and should save you a lot of time. And so I'm really excited to demo this and excited to see how you all use it.
Awesome. Thank you so much, Sid. Yeah, it's like we're very excited for this one as well. Currently supported for Postgres sources. It's supported for all of our other source types, SQL Server, MySQL, etc., coming very soon. So definitely let us know if as soon as you had a chance to use it.